Good morning, students. Today is the day 3 and the concept is matrix, symmetric matrix. Now what is symmetric matrix? A square matrix A equals to Ij is symmetric if Aij equals to Aj for all Ij. I repeat, a square matrix A equals to Aij is symmetric if Aij equals to Ji. I means rows, J means columns, and this interchanges to I becomes J and J becomes I. For example, if A equals to 3 minus 1 1 minus 1 2 5 1 5 minus 2. Now A13 means A11 A12 A13 is 1, but if we interchange 1 3 3 1 31, so the 31 is also equals to 1. For example, if A23 means A21 A22 A23 5. Now A32 31 32 5. So A13 and A31 equals to 1, A23 A32 equals to 5. So Aij equals to Aj. The condition A transpose equals to A. Now the basic condition for the symmetric matrix is A transpose equals to A. Now we know the value of A is given 3 minus 1 1 minus 1 2 5 minus 1 2 5 1 5 minus 2 1 5 minus 2. Now what is A transpose? Transpose is changing of row into column. So 3 minus 1 1 minus 1 2 5 1 5 minus 2. So A transpose equals to A. So A is symmetric matrix. So I repeat, what is symmetric matrix? A square matrix Aij is symmetric if Aij equals to Aj. Means A13 equals to 1, A31 equals to 1, A23 equals to 5, A32 equals to 5. And the basic condition for the symmetric matrix is A transpose equals to A. The value of A is given. And now we find the A transpose. Transpose is changing of row into column, second row into second column, third row into third column. So A transpose equals to A. This becomes A is a symmetric matrix. The next concept is skew symmetric matrix. What is skew symmetric matrix? A square matrix. Remember one thing, square matrix. The matrix must be a square matrix. A square matrix A equals to Aij. What is I? Rows, J columns. Is a skew symmetric matrix if Aij equals to minus Aj. For example, if there is a matrix given A equals to this 0 2 minus 3 minus 2 0 5 3 minus 5 is 0. Now what is the value of A12? What is A12? A11 A12 2. If we change I and J, this becomes A21. Now what is the value of A21? Minus 2. Those are the difference is the minus. So again the value is A13. The value of A13 is A11, A12, A13 minus 3. But if we interchange the rows and columns, this becomes A31. A31 is 3. Again the difference is of minus sign. Next A23. A23. Now A23 is A21, A22, A23. 5. Changing row into column. the element becomes A32. Now A32 is minus 5. So Aij equals to minus Aji. Now the condition for skew symmetric matrix. Skew symmetric matrix. The condition is A transpose equals to minus A. Now, what is A transpose? Transpose is, we know, the changing of row into column. Again, the second row becomes second column, third row becomes third column. Equals to minus, what is the value of A? A is 0, 2, minus 3, minus 2, 0, 5, 3 minus 5, 0. Now 0 minus 2, 3, 2, 0 minus 5, minus 3, 5, 0. Multiply the whole matrix by minus. So this becomes 0, minus 2, 3, 2, 0, minus 5, minus 3, 5, 0. So this shows A transpose equals to minus A. If this condition is satisfied, we can say A is a skew symmetric matrix. I repeat, a square matrix A equals to Aij is a skew symmetric matrix if Aij equals to minus Aji. So the basic condition for skew symmetric matrix is A transpose equals to minus A, but in symmetric matrix A transpose equals to A. Now we shift to the theorems regarding symmetric and skew symmetric matrix. The first theorem, for any square matrix A with the real number elements, then A plus A transpose is a symmetric matrix, A minus A transpose is a skew symmetric matrix. We explain this concept or theorem with an example. For if A equals to 1, 5, 6, 7. Now A plus A transpose A plus A transpose, we assume this equals to C. Now what is the value of C? A is 1, 5, 6, 7 plus A transpose 1, 5, 6, 7. Now C equals to 1 plus 1, 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14. So C equals to this, but we have to prove A plus A transpose is symmetric matrix. So if C is a symmetric matrix, then C transpose equals to C. Now C transpose is 2, 11, 11, 14. What is C? What is C? 2, 11, 11, 14. So C transpose equals to C. So that means A plus A transpose is a symmetric matrix. The most important thing is we assume A plus A transpose equals to C. So the value of C is A plus A transpose. This becomes 2, 11, 11, 14. Now we have to prove the symmetric matrix. So C transpose equals to C. C transpose equals to C. Both the values are same. So we already proved A plus A transpose is a symmetric matrix. Now we prove A minus A transpose is a skew symmetric matrix. Again we assume D equals to A minus A transpose. So D equals to, what is A? The value of A is 1, 5, 6, 7. So 1, 5, 6, 7 minus A transpose 1, 5, 6, 7. Now D is 1 minus 1, 0, 5 minus 6, minus 1, 6 minus 5, 1, 7 minus 7, 0. Now we have to prove skew symmetric matrix. The condition is D transpose equals to minus D. Now what is D transpose? So D transpose is changing of row into columns. So 0, minus 1, 1, 0. Minus, what is the value of D? What is the value of D? 0, minus 1, 1, 0. So 0, 1, minus 1, 0 equals to 0, 1, minus 1, 0. So hence we again proved that D transpose equals to minus D. So if D transpose equals to minus D, it means D equals to A minus A transpose is a skew symmetric matrix. I repeat. We have to prove A minus A transpose is a skew symmetric matrix. We assume A minus A transpose equals to D. Now we have to find the value of D. So D equals to A minus A transpose. The value of D is this. Now we prove D transpose equals to minus D. We put the values of D transpose as D. So left hand side equals to right hand side. Hence we prove that A minus A transpose is a skew symmetric matrix. Now we shift to the theorem second. Theorem second states that every square matrix A can be expressed as a sum of symmetric matrix and skew symmetric matrix. Any square matrix A expressed as a sum of symmetric matrix and skew symmetric matrix. Now, if we divide this symmetric matrix by 2, this remains the same. This will not change. Again, if we divide skew symmetrics by 2, this will also remain the same, that is skew symmetric matrix. Now we suppose this part equals to P and this second part equals to Q. Now what is P? Half A plus A transpose. Now P equals to half. What is the value of A? 3, 2, 3, 4, 5, 3, 2, 4, 5 plus A transpose. A transpose means changing row into columns. So 3, 2, 3, 3, 2, 3, 4, 5, 3, 4, 5, 3, 2, 4, 5, 2, 4, 5. Now P equals to half. Now 3 plus 3, 6, 2 plus 4, 6, 3 plus 2, 5, 4 plus 2, 6, 4 plus 5 plus 5, 10, 3 plus 4, 7, 2 plus 3, 5, and 4 plus 3, 7, 5 plus 5, 10. So in this way we can find the value of P. Now we find the value of Q. What is Q? Half A minus A transpose. Now half. What is the value of A? The value of A is 3, 2, 3, 4, 5, 3, 2, 4, 5 minus A transpose 3, 2, 3, 4, 5, 3, 2, 4, 5. Now half. 3 minus 3, 0, 2 minus 4, minus 2, 3 minus 2, 1, 4 minus 2, 2, 5 minus 5, 0, 3 minus 4, minus 1, 2 minus 3, minus 1, 4 minus 3, 1, 5 minus 5, 0. Now, in this way we find the value of Q. But there is P plus Q. Now A equals to P plus Q. So A equals to, what is the value of P and Q? So this is value of P and this is a value of Q. So half, in these two values we can take half as a common. So half. So 6 plus 0, 6. 6 plus 6 minus 2, 4. 5. 5 plus 1, 6. Again 6 plus 2, 8, 10 plus 0, 10, 7 minus 1, 6, again 5 minus 1, 4, 7 plus 1, 8, 10 plus 0, 10. Okay, I repeat, A equals to P plus Q. The value of P is this, the value of Q is this. In these two values we take half as a common, we add first term, second, third, vice versa. And now divide all these numbers by 2. So now we divide this whole matrix by 2. So 6 divided by 2, 3, 2, 3, 4, 5, 3, 2, 4, 5, 2, 4, 5. Now the final answer is 3, 2, 3, 4, 5, 3, 2, 4, 5, which is exactly the same as the value of A. So we conclude A equals to A. This is the whole process of any square matrix which can be expressed as the sum of symmetric and skew symmetric matrix. The formula is A equals to half A plus A transpose plus half A minus A transpose. This is a symmetric part and this is skew symmetric part. So we assume this part as P and this part Q. We find the value of P and Q and add both the values of P and Q. The final answer becomes A. So A equals to